Assalamualaikum and very good morning, everyone. So, thank you for being here today. So, we will present about the subject statics. The code is BDA 10203. So, the topic that we will present is simple trust, which is the simple trust is in the structural analysis chapter. So, we are from group 9 from the section 6 will present about the simple trust. So, in this presentation, we will explore the essential role of statics in engineering problem solving. Specifically, we'll focus on how concepts like equilibrium, distribution, and mathematical modeling help analyze and design stable structures such as trusses and load-bearing systems. By applying method like the method of joints and method of sections, we ensure the safety, efficiency, and cost effectiveness of engineering designs. The study not only highlight the theoretical importance of static but also demonstrate its practical application in real-world scenarios. So let's dive in and see how the principles contribute to solving engineering challenge and building safer, more reliable structures. So, before we continue our presentation, I will introduce my group members. First, my name is Ehsan Mubarak bin Abdul Kadir, matric number CD 240380. So, my group member is SRITHARAN anak lelaki Raja, matric number CD 240369. Then Muhammad Arif AKASYAH bin Abu Bakar, matric number CD 240346. Then Muhammad Yusuf bin KAMARUL AZMAN, matric number CD 2403367. And the last one is Muhammad Shafi bin MOHAMMAD AMIN, matric number CD 240381.
Hello, everyone, and welcome to my presentation. Let me start by saying a few words about my own background. My name is SRITHARAN. My metric number is CD240369. As you can see on the screen, our topic today is about simple truss. Let me start with the introduction. Static as subfield of mechanics focus on the force affecting system at equilibrium where all the force are and the moment balance to prevent motion or deformation based on Newton's first law of motion. The truss analysis engineers apply the method of joint analyzing each joints to determine force in connected members. And the method of section is isolating specific section to efficiently calculate internal force. Both methods ensure stability and safety by balancing force and moment. Our assignment explore the practical application of simple truss in structural design, analyzing force through mathematical mode to understand their relationship and reinforce static principles. This hands-on analysis enhance our ability to design safe, efficient structure and withstand various load and conditions, preparing us to address future engineering challenges. Moving forward, let me explain the literature review of our group project. The analysis of simple truss in a foundational topic is statics, widely applied in bridges, roofs, and modular frameworks due to their high strength to weight ratio and efficient design. Developed through the contribution of pioneers like Cauchy and Maxwell. Trust analysis relies on key assumption. Members are connected by functionless pins. Loads act only at joints, and members experience only axial force. Hibler 2021. Two main techniques are employed. The method of joints ideal for smaller truss and the method of section efficient of analyzing specific members in larger structures. Trusses are integral to engineering but face challenges like compression, members, bulking, and idealized connection. With ongoing research addressing these limitations through improved material and joint design. Beer et al. 2020 and also Chi So 2020. Thank you so much.
We will present about problem statement. Now we have three problem statements. First, if the load from the car is too great for the bridge to withstand, be it from a vestige weight or height speed. It also cover factor include car weight, distributing the strength and stability of the bridge. And second problem, the load bearing capacity of the truss frame employed in the roof of the building. Okay. Think about how load are distributed roof with load, wind force, worker load during construction. And the last problem is roadside have different truss depending on size, width, weight, wind load, and local design code. Now, it need to be proved how the signboard sign design can work will and be safe to use.
Okay, for the situation one, we can see here a car of mass at 100 kilos at 100 kg is on a bridge of mass 20,000 kgs and length of the bridge is 20 meters, which is supported at its two ends, A and B. The car is at a distance of 5 meters from the point B. What is the force required at B from the support for the bridge not to collapse? So we can see here at point A, we put the pin, and at point B, we just use a roller. So from this equation, for the free body diagram, we need to bring out the forces in point A and point B. So in point A, we have the force in x direction and y direction. It because pin we have when we use pin, we have the force in x direction and y direction. So for the point B, we just use the roller. So at point B, it just have the forces in y direction.
My name is Muhammad AKASYAH BAKAR. My meeting number is CD240346. My part is to do the calculation in question 1 and 2. Okay. For question 1, as we can see the FBD, what the question 1 is, we want to balance the car in the force By. So, firstly, in this question, we need to find the weight of the car in Newton. So, for the first weight of the car is 800 kg. We can multiply with the gravity force 9.8. So we get the weight of the car. For net is the bridge. We also need to convert it to Newton by multiplying it with gravity force 9.8. We can assume the Force at A and B, force support by A and B. So the vertical force FA plus FB is equal to weight scar and weight bridge. So we can plus the weight car and weight bridge. So after that, we can assume the moment in the bridge for weight B, and we can get the weight of the car. Weight of the car is weight of the bridge. A moment of the bridge is 90,000 Cs. 196,000, and for the weight of the car is 117,600 Newton meter. This is we convert into the moment by multiply the weight and length. Next, we can see the we can conclude the all moment states equal to 0 to make the equilibrium. So force B, we can find the force B. So force at B is equal to 103,880 Newton to balance the car weight. Thank you for the question 1.
So for the question 2, we can see the truss of the roof. So the station is evaluate the loading bearing capacity of the truss framework employed in the rooftop of the depicted building. Think about how loads are distributed: roof, weight load, wind forces, worker loads during the construction. Find forces acting on key truss member and determine if member are in tension or compression. Analyze if the materials employed are adequate in both strength and rigidity to withstand with force without buckling, in order to guarantee roof stability and safety under the normal loading condition. So from this situation, we need to determine the force in EB of the roof truss, indicate whether the member is in tension or compression. So we can see here, in this question, free body diagram, we need to cut to find the forces in EB and determine if forces is tension or compression. So for this FBD, we need to mark where we want to cut for the easiest calculation. So we have decided to cut the point B and point A. So we can see here, we have plot picture with the where we want to cut it. So we can see the right side picture. We have cut the point A. So the FBD will be like this after we cut. So when we cut it, it helps us to find or to calculate the force in each joint easier.
Okay, for question 2, first we need to find the given for F all the Newton in the question in the FVD. So let's take a look of the FVD. First, in this FVD, we will need to do the cut to find the E and B force. Using this method, it will make us easy to find the EB. Okay, so we can conclude the moment MB is equal to 0 because all moment is equal to 0 because of the equilibrium. So we only, it's very simple, only take all the moment in B. So so we can find force ED equal to 3,000 Newton. Because we get the positive, we can conclude the force is compression. So next, we want to find the FEF force. Stay the same. We can use the sign we have, the FED force ED. We can use the formula force Y and force S is equal to 0. Sign the S and Y is equilibrium. So force EF, we can conclude that we get 3,000 Newton in compression. Sign is will be the positive. Next, we can use the FEB. We can find the FEB, so we get the EF. So we can get the 200 Newton intention, so it will be negative. And that's all for me. Thank you, sir.
Okay, for the last situation, which is it was a road sign. So the situation is road sign uses to have different trusses depending on the size, weight, wine loads, and local design codes. As a result, cantilever trusses are one of the most common type of trusses used for road signs, allowing a large unobstructed signboard to be used prominently for drivers and road users. Designed to support the loads over long spans while doing so without center support, thus pre- preserving improved visibility and usability. They also can act like pin joint trusses that make several triangles for stability and distribute forces accordingly. This structure put the environmental factor of consideration like wind pressure in the structural design in making sure signs are secured at any time they are viewed. It ensures that appropriate truss design employ their potentials so road signage would prove to be both functional and enduring.
Okay, thank you Akasha for the explanation on calculation. So I, Muhammad Yusuf bin Kamarul Azman with matrix number CD240367 will explain about discussion and conclusion for our groups. Okay, for discussion, static plays a vital role in engineering problem solving by enabling the analysis of forces and ensuring structural stability. By applying equilibrium concept such as moment and vertical force equation, we calculate force in scenarios like bridges, guaranteeing stability under specific loads. Idealized assumptions such as frictionless joints and negligible members weight. Simplify calculation but highlight limitation when applied to a real-world structure. Understanding load path prove essential, as errors in calculation could lead to unsafe design or over-engineering, impacting safety and cost. The assignment demonstrated the effectiveness of method of joints and the method of section in analyzing truss systems, with each method offering unique advantage depending on the structure complexity. Overall, the importance of selecting the appropriate analytic method to improve accuracy and efficiency in engineering practice was emphasized. So we already done with the discussion. Now we can go through the conclusion. So for the conclusion, this study effectively applied static concept to analyze and resolve structural issues in load-bearing system and trusses. By using equilibrium equation, the forces acting on key structural components were identified, ensuring stability under various loads. The analysis reaffirmed the effectiveness of the method of joints and method of sections in determining whether truss member experience tension or compression, which is crucial for structural soundness and resource optimization. While idealized assumptions like frictionless joints and negligible members weight simplified calculation, they highlight limitation in real-world application. The study emphasized the importance of accurate load analysis, careful modeling, and iterative verification to ensure safety and cost efficiency. Overall, this is work underscored the value of mathematical rigor and adaptable problem solving in tackling complex engineering challenge.
Now, these are our reference throughout this project. All the reference are taken from the internet. First, about mechanic of material night edition from Miss Crow Hill Education. Then about engineering mechanic static 15th edition from recent edition education. Then about theory of elastic stability 2 edition from Mr. Crowhill. After that, about engineering mechanic static 9 edition from Willie. Next, about structural stability theory and implementation from CRC Press. Then about research on the application of analysis to the equilibrium of solid translate edition from Paris Bachelier. Next, about unreciprocal feature and diagram of force from um, Philosophical magazine. And then about mechanic of material 8th edition from Shigalini. And then about advanced strength and applied elastic 5th edition from Person Education. And the last, analysis and design of tension structure from the work scientific. Okay. That's all happen as in complete the project.
Okay, that's all from us. Thank you so much.